Did you edit out that last part yesterday?
I will later. No. All right, let's do this harder one, okay? This one, I want to do them in all kinds of positions here. Now, this guy here, I bet you have some wrong on this one. Let's assign the priorities first, okay? First, highest priority is 1 for bromine, 2 for chlorine, 3 for this guy, and 4 for that guy. All right, and here's what happens in this guy. People just say, okay, I know how to do this. 1, 2, 3. I'm going clockwise. It's R again. Y'all have R?
Yes.
Because it's wrong. It's not R. Now watch and listen. What did I say you had to do? You have to look through the molecule down the bond of lowest priority. Right now, this molecule is oriented, so I'm looking at it exactly the opposite way. Let me show it to you with the model, okay? Kate Upton, please. Come in. No. All right. Let me show you with the model. You ready? Here's my H. Here's my Br. Here's my CH3, and here's my chlorine. I am now looking at it this way. That's the exact wrong way to look at it. Where do I have to look at it? From this side. So everything I'm looking at is backwards. I have to turn all the way around this way. When you go to draw 1, 2, 3 as R, looking at it from this direction, that's clockwise. But if I get behind it, it's what? Counterclockwise, which makes this guy S.
So my way didn't work.
Well, it will work if you rotate. Again, I said you had to be able to rotate it. Watch what happens if you do what you were talking about doing, rotating it in your head. If I rotate this guy around, what happens? I rotate this guy back. Now the bromine's over here, the CH3 is over here, and then when you draw it, it will work. Okay? But again, I guess probably the easier way to see this is really not to see it at all, but just to realize that if it's coming out at you, it has to be the exact opposite, right? It has to be. Let's try one more. I'll erase both of these guys, and we'll try one more of the harder type, okay? Try drawing this guy. All right, try doing the R and S, whatever it is, and the priorities of that guy. I mean, the priorities by now, at least you're going to get some partial credit. By now, I'm sure everybody can do the priorities. 1, right? 2, 3, and 4. And I'm kind of using the same elements most of the time anyway, just because you're getting used to seeing the colors on the models. All right?
Different colored models.
Different color models. We're not racist here.
No, no.
Okay, you trying that one? This is one of the harder ones to see. You got to get, where do you have to look at this guy from? Yeah, you got to get underneath the model and look up. And when you do that, figure out what you're actually seeing here.
This is hard.
It is. It's very difficult. But there he is. There's the model. Y'all have an answer? Y'all think you know what it is? Let's see if you got it right. There's your model. There's your H. Up here, lowest priority bond. I got to look this way at this guy, up that way. When I do that, my number 1 guy is here. Number 2 is there. Number 3 is there. What am I drawing? Did you all have that?
Yep.
No? Yes? Most of you seem to have had R. And that's what he is. Whoops. Sorry.
The opposite.
Okay? So these are tough. All right? Those are the harder ways to do them. Let's now, if you thought that was bad, now we're going to get to when we have more than one chiral center. Something called, we have to get through all these again.
Can you give us a model on our test? And then we
Absolutely. You know, a lot of, you can make your own. I'm not going to actually give you a model kit. But if you want to bring in, this is what people do, you know, like gummy bears or different colored marshmallows, and you make your own models, you can do that. You can use them to help yourself on a test.
If I buy a model set.
If you buy a model, that would be called slavery. You can't have models.
Why can't you just be serious?
He was trying to do that last
I'm buying a model set.
Yeah,
he was fair buy.
things on.
No, I don't want you to buy a model set. I don't want you to spend money on it.
Just make our own.
Why?
Make your own models.
I could use
Like
a
in
bunch.
that movie, Weird Science, where he probably never saw it.
No.
I'm gonna get ping pong balls and paint a different color. That's what we do.
Okay,
That's what we do.
diastereomers. Let's talk about this where you have more than one chiral carbon. Stereoisomers that are not mirror images. That's a terrible definition, all right? But basically, that's about the only way. It's when you have multiple chiral centers, some of which are and others are not actually mirror images, okay? You have 2 or more chiral centers in order to be a diastereomer. They must have 2 or more. Okay? All right. Now, I'm going to draw these guys as Fisher projections. It's just a lot easier. And once again, you got the room down there? Once again, you're going to want to do this. You're going to want to draw one here, leave some space, draw one over there, all right, and leave room underneath it to probably draw a couple more examples as well. But I have to draw these guys as Fisher projections. Just make it a lot easier to do them, okay? And because they have 2 carbons, I'm going to basically be doing this. I'll only make the backbone so you know how much room to leave. All right, I'll make the backbone. Oh, I want to use black. Make the backbone of each of. I want to use black. Hey, it'll be like that, and another one over here like this. Okay, and we're going to see how they compare. Now, first of all, you can draw, but I don't want you to do it right in between. I want you to do it down here in between. All right, you can draw what these things really mean. These are equivalent to a carbon. Again, remember, scoot it down a little bit. A carbon and a carbon in the plane of the board, like this. See it? Okay? I've got these 2 guys are the only things that are going to be in the plane of the paper or the plane of the board. Those 2 carbons right here. Now, notice there's going to be 2 guys sticking out at you. Like the Fisher projection, the guys that are on horizontal lines are sticking out at you. And the guys who are on vertical lines are actually going back into the paper.
So the 2 lines going across are sticking out.
Right, yep, yep. So that's what these things mean. That's what each of those things mean, okay? Now, let me draw them for you and show you how you can determine whether they're R or S. I want to do 2 examples here. We'll start with CH3 up here, Cl and F, H, I, and Br.
Are both of these going to be able to test the Fisher projection thing?
Yeah, you could have either one, or I'm almost definitely going to have guys like this who are double chiral centers. I'm almost definitely going to have them drawn as Fisher projections.
Okay.
Just because it's easier. All right. Now, these, of course, are going to be harder. You have to keep in mind, you've got 2 chiral centers here. And let's make the top one red here. I'll use red. There's a carbon here and a carbon there. So let's make this guy, you don't have to draw that carbon in there. I'm just saying there is a carbon there. Let's assign the priorities around that carbon. Okay, who's got top priority around that carbon? Who's the heaviest thing? Cl. Everybody agree on Cl? Good. Who's next? F, no doubt about that. But the next one's going to be a problem. You got your methyl here, which is what people said in their class. But what is this guy also? He's a carbon as well. Who wins? This carbon or that carbon? Yeah, this whole thing gets 3rd priority for this guy. And 4th priority is him. Now, I purposely drew this one like this first because he is, with the lowest priority bond, going into the paper. That's where the 4th priority bond. That's nice. All I have to do is connect the dots with this guy, right? What will this guy be? 1, 2, 3. What is he? What am I drawing? 1, 2, 3. Everybody agree it's S?
Yep.
Okay. Now, if we look at the other guy over there, again, sticking with the red for the top, we'll use blue for the bottom so we don't confuse them. Same basic priorities but they're not in the same places. Here's 1, here's 2, here's 3. Even though there's a tie between the carbon here and the carbon there, this carbon wins. He's bound to something else that's heavier, like the iodine and the bromine. And then this guy is 4. Now we have a problem. The 4th priority bond is where? He's right here on this spot, coming out at you. So when I go 1, 2, 3, and it looks like he's what? What does he look like he is?
S.
S. He's not, because I had to get behind that guy. I had to get behind him. Let me show you where he is here. Fluorine, chlorine back there. I'll have to make this guy fluorine. All right, if you can see him. All right, I'm only looking at the top here now. You see it? All right, I've got my methyl coming out, my chlorine going straight back, and I've got my my fluorine over here. This orange guy's got to be the fluorine in this case. All right, so I'm actually have to get behind this guy because this guy's coming out. I have to look this way. So whatever I drew here, 1, 2, 3, I thought it was going to be counterclockwise. It's actually the opposite from the back. So he's clockwise, or R. So what do I notice about the top half of these? Top half of these two guys are mirror images. They're not the same. But can you already see, without doing RRS, can you see what the bottom half is going to be? They're going to be the same. How could you see that? HIBR. HIBR. They're both exactly the same things. Whatever I put for these preferences, or these, what do you call it? Not preferences. 1, 2, 3, right? Not preferences. What do you call this? When you assign the priorities, that's the word. Jeez, little brain freeze there. All right, whatever I assign for the priorities, it makes no difference. H, I, and BR are going to be the same. Let's do it. I'll just in case you don't believe me. Number 1 is going to be who? Who's the heaviest guy down on the bottom? We use blue this time. 1, 2, 3 is the whole thing, and 4 is this guy sticking out at you, right?
Right. I'm just not going to do it. I'm just going to scoop it.
All right. So if I do this guy, again, you have to be able to tell whether he's R or S at least. Can I tell if he's R or S? Sure. I've got my 4th priority bond is right here. It's coming out at you. So whatever I draw here, what's it going to be? The opposite. So what am I drawing here? 1, 2, 3. What am I drawing? Looks like it's what?
Clockwise, but it's not counterclockwise.
So it's actually S.
That's what I'm doing for everything.
Okay? If that guy's S, what is the other one going to be? Also.
S.
S, because he was exactly the same. If I do this, I'm going to get exactly the same preferences, exactly the same numbers, priorities, I should say. And there it is. Now, here's the crazy part about this. The top half is unequal. The bottom half is equal. So they're not mirror images of each other. Only one part of it's a mirror image. The other part's not. They're called diastereomers. Okay, these guys are diastereomers. All right, because you have the top half being not the same. And by the way, does it have to be top and bottom? No. The bottom half could have been unequal and the top half equal. And they would have also been diastereomers. The key is this. One of the 2 chiral centers is a mirror image and the other one is not. And that is what makes him a diastereomer. What would have happened? Let me show you the other possibilities. Okay, matter of fact, I'm not even going to do another example of this one. I think that's enough for right now. But I do want to show you some of the other possibilities. You ready? Watch this. If you have room, you could write some of these down. But you know, it may be confusing right now. We'll come back to this later. So just kind of want to listen to this. All right, watch. Say I have this. I do this guy, and I get R, R, S, S. What do I call those 2 guys? Nope. They are not diastereomers. They're not triastereomers.
No, is it a dientomer?
It's not a di. It's just a what? What's the word? It's an enantiomer. This guy would be an enantiomer. Because the definition of an enantiomer is a guy who's a mirror image. And this is an exact mirror image. The fact that there's 2 chiral centers doesn't mean you can't have an enantiomer. You can. But are these enantiomers? No.
Why?
No. They're not enantiomers unless they're mirror images.
They're not.
Are they mirror images?
No.
If this is R and S and that guy's R and S, the top half is equal and the bottom half is equal, what do we call those guys? Identical. They're the same. They're exactly the same.
That's what's called identical.
They're just the same. Or same, whatever. Okay?
Wow.
All right? But now let's do Lizzie's, the one she wanted to do. Okay? Again, you're not trying to draw these because I'm just doing these quickly. Say I do it, I have R, S, and S, R. Now, the top half is unequal, the bottom half is unequal. What are they? Those are enantiomers, right?
How do you say that word?
Enantiomer.
It is.
I don't really pronounce it. It's like stoichiometry. I always just say stoichiometry, enantiomer.
That's how you actually have to say it. So
I mean, technically, I suppose. It does have the OI,
We were right.
yeah, but I just call it.
So if it would have been on the top R, R, and on the bottom S, R, it would not be an
Well, let's do one. All right, what if I have this? All right, we have R, R at the top, and we have S, R at the bottom. Well, what is that?
That's it. This.
That's a diastereomer.
That is it.
Okay? All right, so you have three possibilities for these guys. All right? You can have the top halves both equal, one unequal, one equal. It doesn't matter if it's the top or the bottom. All right? Or you could have both halves unequal. All right? And what are your options here? Identical. This guy would be a diastereomer. That guy would be a diastereomer. Or what?
An enantiomer.
An enantiomer. There you have it.
And then it's